Hello everyone, my name is Rahul and today's session is on the Traceroute, a network diagnostic tool. And this tool is useful by most of the network engineers, right? And to begin with the sessions, let me give you the brief about myself. My name is Rahul Maurya and I am having around 17 years of experience in voice domain as well as some experience in the network data networks, right? And this session is for those who are actually looking their career in the network field and they want to start from some point, and this is the good point you can start with to learn the basics of the networks. Before the session I prepared one more session on ping, right? And also this session is useful for those who are working in industries and on that L1 level, L2 level or L3 levels, right? Because in daily uh, life or daily operations work, they have to troubleshoot the issues, right? And these tools can help them to identify the problem area and get those rectifications, right? And I have prepared these sessions for those uh, people who are looking for the job change or preparing themselves for the interviews, so that in my session I will put some questions and try to answer those questions so that you can understand the things in a better way, right? And in case if you are going or preparing yourself for the next level, or you're preparing yourself for the interviews, you can answer those questions, right? Because in my past experience I have taken so many interviews and I know that some things sometimes engineers are missing their basics, right? So that's why these sessions are all about, right? So let's start then. So what is a trace route? So trace route is a network diagnostic tool used to track the path that data takes from one computer or to the other computer or other network, right? What does it mean? So whenever there is a network and uh, and you need to know how the traffic is going from your laptop or from your device to the other device, right? You can use the trace route to identify those things, right? In my next slides, in upcoming slides, I will show you the practical examples, right? In that case you will get more clarifications, right? And it also identify each hop on the router path and measure the time taken for each hop, right? And it's also useful for diagnostic of network delay or any failures in the network, right? And how it works. So generally, whenever we start the trace route from any of the device, whether it's a laptop or whether it's a network switch, whether it's a network router, it sends a packet, and there is a value of hops that is we mention as a TTL, time to live, and generally it's a 30 hops, and we can manipulate it. Well, I will show you how we can manipulate it. So whenever we trace any device, our device will send the packets to the destinations, and whenever my packets is traversing to the network devices, it decreases the TTL value by 1, and once it reaches to 0, it means there is no path or nothing is there, right? So every incremental means one hop in the networks to the destination. So and traceout records the round time trip time for each hop. I will show you how. This is an example of one of the trace route, right? So from my laptop, I ping one of the device, and it says that trace route to this device, correct? And here you can see over a maximum of 30 hops. So that is what the TTL means. So time to live means here it's 30. So it means my packets from my laptop, it will hop to the 30 network devices. If it's I'm pinging, I'm tracing any device which is far away from my laptop, so it will reach to the 30 hops in between. So I'm pinging one of the device, right? So that IP is 10.128.78, then 70.70, right? So you can see the response. This is a serial number or hop number. I can say the TTL values 1, 2, 3, 4. It will reach to the maximum 30 hops, right? And if you go oh, horizontally, you can see 3 millisecond, 1 millisecond, 2 milliseconds, right? So what does it mean? It means that my traffic is generated from my laptop and it's reaching to the next hop, and this next hop I'm sending three packets, right? First packet, the round trip time is 3 millisecond. Second packet, it's 1 millisecond, and third packets, it's 2 milliseconds. So here I can say that my first packet reached to the this IP address, and then the second I, packets which reaches to the this IP address. Likewise, it will reach to the final IP address. Correct. And here you can see the host name of the devices which are there lying between my device to that final device. Correct. And somewhere you can see that the timing is increased at 10 milliseconds, 9 milliseconds, 10 milliseconds, right? And here you are seeing that 24 milliseconds, 7 milliseconds, 7 milliseconds. So that means whenever any packet is generated from my laptop to the destination which I'm tracing, the round trip time is this much. Correct. So if there is any issue in the circuits or in your network, you will see the increased time value. So likewise here, you can see 10 milliseconds. Might be it's let's say it's 100 milliseconds, and then again let's say 50 milliseconds and 30 milliseconds, and then in the next hop it shows less than 10 millisecond, right? 9 millisecond. So that means the packets which is uh, traversing to this hop, right, is consuming more time. So you can interpret like that, uh, might be there is some delay in this device, right? Might be if you are tracing any device which is far away and the traffic is going via internet, and if you are seeing such delay like 100 millisecond 200 milliseconds in between your trace route, so you can identify that this service provider might be Tata or any service provider is having any issue in their network. That's why there is it's the packet is taking too much time to trace over there, right? And here you can see there is another variant of the traceroute. So uh, in traceroute minus D and then the IP address, right? So here I am tracing out one of the IP address with the minus D. So what it will do, it will remove the domain name of the devices which are there in between. Because in previous slide, you are seeing the domain name and host name of the devices. And if you doesn't want to display, you can run the command traceroute traceroute minus D, the IP address, right? So here you can see that first hope uh, we are not seeing any host name and the domain name over here, right? And also what I was saying to you earlier, that here you can see that on the seventh hop the timing is 90 millisecond, 9 millisecond, 13 milliseconds, and after that it's 9 millisecond, 13 millisecond, 9 millisecond, right? So I can see that there is some delay on these routers, right? So that is what you can consider while tracing this any of the IP address. And on the 10th hop and 11th hop you are seeing the star. So what does it mean? That it says that request timeout. So if I'm tracing any device which is outside of my network, right? And if there is any firewall or any device might be some firewall, let's say, and it's not responding to that the trace packets, right? But what it do, it will not respond to that packet, right? But on the other side, it will pass that packet to the next hop. So the device which is there on the hop 10th and 11th, it is not responding to the trace packets, but what it does, it just pass those traffic to the other hop, right? Which is there on the next hop, I can say, right? So the next slides, it says, oops, uh, the trace traceroute minus h, then the IP address, right? Sorry, I have to mention some number over here. So earlier, we were tracing of any device with the default values, right? Default hop values. That hop value we can manipulate like this. You have to run that command traceroute minus h, then the number of hops on which you want to trace those, the IP address, right? So here it says 5 and the IP address. When you run this command, you will see that only the 5 hop, right? And the next is trace from the router. So earlier I was showing you the trace from the any of the laptop or desktop machines, right, to the destination IP address. But you can also start trace any of the device from the router itself. So if you log into any of the router, just the command over there, there is a trace route and then the IP address. You will get the same informations like you were getting the on the Windows machine, right? But here you can see that the number of one, and you are seeing the response from the two or three devices, right? So it means to reaching the from this router to this destination IP address, there is a three path, and you are seeing that every path, the packet from every routers, right? So from first router, it's 12 milliseconds. If the packet is going to the second router, it's 1 millisecond, and less than 1 millisecond on the third router, right? So here also on second hop, you can see there's a three path which can travel to reach this destination IP address, correct? And likewise third, it's taking time, 3 millisecond, 4 millisecond, 4 millisecond, 4 millisecond, like that, right? So that's what these are the useful commands which you can use in your daily operations work, right, in the network field. So the mainly use cases is to check the slowness in the network. If there is any slowness in the network, you can run these commands and identify which device is causing problem, right? And you can take the action accordingly. So mainly this is used in the service provider network. If we are pinging or tracing any of the device which is there in the network internet, and we are seeing any delay or any latency, we can identify those things from the trace route, and we can engage our service provider to fix that problem, correct? And also if there is any loop in the network, that is also can be can be seen from the trace route. So by default, the number of hops is 30, right? But if we are not getting response within that hops, that means there is some loops in the network. That is also can be identified with the trace route. Uh, so we can trace out any of the website or any of the server, right? And list out the hops or the router devices in between from my network to that particular IP address, right? And also we can identify the network path which is used by the service provider. And there is some limitations of the trace route that firewall may or may not be block the trace route packets, which I explained earlier. So we were seeing star star. That means that packet is not processed, but it is forwarded to the next level, right? And some of the router might be there as some access list, which is also not configured like that to respond to those trace out packets, right? And result can vary due to the dynamic routing also. So the summary, I can say that we have learned how the trace route is working in our network infrastructure, and you can check the network path and identify any delay if is there in the network with the help of this, and also supporting network troubleshooting. Correct. Uh, so one thing, there is a one difference between the trace route and the ping, right? So which generally interview can ask you what is the difference between the trace route and the ping? And the simple exam answer to this question is in ping we are getting the response from uh, the round trip response from the end IP address, right? From the destination. But in the trace route, we are getting the response or round trip time from each hops, each network devices which are lying between your destination IP address. So this is one of the questions generally interviewer can ask you during your interviews, right? And if you have any question or if you need any slides, you can just uh, mention that on the comments. I will answer those questions for you. And thank you so much. Thanks for your time. Have a nice time. Bye bye.